All right, so let's take a look at this problem number one. For your reference, I've put the y equals sine of x here and the five basic points on there, primary points. To determine the period, we always take 2 pi divided by the coefficient in front of x. And then, of course, reduce your fraction. So the period has now been the graph has horizontally shrunk. Remember that when you're affecting the domain, it's counterintuitive. You know, I often say it's bizarro world. It's bizarre that you would see 4 times x, but really you divide by 4. So you're taking this 0 to 2 pi, this period that it completes one cycle, and you're shortening that cycle. You're horizontally compressing the graph. Then the amplitude is the number that's in the multiplier that's in front of the sine or cosine. And since both of these are represent distances, then you want those to be positive numbers. Now your center line, it is a line, and it's a horizontal line, so we always need to write it as an equation, and it's what we're adding or subtracting to this sine or cosine curve. So are you lifting the graph up or are you pushing it down? In this case, we're doing neither. The center line remains y equals 0. So now to think about where it crosses the center line, if we think about where it crosses the center line on this 0 to 2 pi, then what this 4 is doing is shrinking that. So instead of intersecting the graph in 2 places, because see we're not, this should be a hollow dot at 2 pi because we're not considering that endpoint. So here it's crossing the center line twice, but now if you compress that distance and you still look at 0 to 2 pi, it's now going to cross it 8 times. So let's take a look and I'll show you how to write those out. We know the sine of 0 is 0. We know that when the input is 0, you're on the center line. So let's take this expression 4x and replace it with 0. Okay, solving that for x, we have that x equals 0. So we're at the start of our interval here that we want to list where it's intersecting the center line. So the next place here that's intersecting the center line is when the input is pi. So if we replace 4x with pi, meaning that if we let x equal pi over 4, then when you substitute that in, you're going to have the sine of pi, and it's going to be at the center line, it's going to be 0. And the one thing about this intersecting the center line, that it's equally spaced. So if the distance between these two places that it's intersecting the center line has the length of pi over 4, at every jump of pi over 4, you're going to end up on the center line. So we've got 1 pi over 4, 2 pi over 4, which just reduces to 1/2. We've got 3 pi over 4. Then we have pi, because if you add 1/4 to that, 4 over 4, the 4's cancel. Then we have, let's continue over here. If we add pi over 4, we've got 5 pi over 4. Then 6 pi over 4 reduces. Then 7 pi over 4. Now, at 8 pi over 4, we're going to stop because that's 2 pi, and that's not on this interval. We're excluding that endpoint. So that's why I say that I knew to expect 8 places where I intersect the center line. So 2, 3, 4, 5, 6, 7, 8. So I have them all listed. Now, if they're not having us do it on an interval, you know, from 0 to 2 pi, which is, they commonly pick that interval. If they just say over the graph's domain, over the set of all real numbers, then at times it's easier, or at least shorter. You don't have to list all of these out. It's impossible to list an infinite number of places where it intersects the center line. So we describe it with an equation. We just pick a starting point. It doesn't matter which one we pick. I'm just going to go ahead and pick 0. And then we add multiples of half of the period, the distance until it hits the next center line. So pi over 4 and multiples of pi over 4. So there's where they often refer to this as the general formula or general solution for where it crosses at the center line. So before I stop the video, I do want to show you, I went over to this Desmos graphing calculator, and from 0 to 2 pi, I graphed one cycle of our sine curve. And this 4 of x, like I say, it's not going to stretch it, it's going to compress it. And when you graph those on top of each other, you can see if I start here at 0 and count these, and I don't count at 2 pi because we're saying strictly less than 2 pi, we've got 1, 2, 3, 4, 5, 6, 7, 8 places where the graph intersects the center line. And you can also, if you type the letter A, it'll say to add a slider bar, and that's what I did here. So if I want to kind of experiment to myself and say, well, what effect does this coefficient have on the graph of the sine of x, I can add one of these sliders, and I can, if I increase that, like if I make that a multiple of 2, then, well, it's not, there we go. Then instead of crossing the x-axis, twice, it's crossing it 4 times, in comparison to, see, I shortened the cycle, I shortened the period, and you can play around with it. And I think if you hit play right here, it just automatically, kind of adjusts and show you. Now there you're stretching it, so I can, let's pause this. Well, it's going to let me pause it. Yeah, if I extend this 0 to 2 pi out to, like, 4 pi, or maybe even 6 pi, and we look at it, if we hit that play. So there, now with the negative, I don't know how to restrict, instead of bouncing back and forth between -10 and +10, to just have it do it between 0 and 10, because the negative there is a reflection across the y-axis. But anyway, you can play around with this Desmos graphing calculator, and it's kind of neat. Talk to you later. Bye.